This is the geometry review, starting with Unit 9. We know that BC is a radius of circle C, and AB is a tangent to the circle. So we can find the value of x by working with the Pythagorean Theorem, because a tangent line is always going to be perpendicular to the radius where the tangent line touches the circle. So of course we know that the hypotenuse squared equals leg squared plus leg squared. So 80 squared is going to equal 48 squared plus x squared. So if we take 80 squared, we get 6,400, and 48 squared, we get 2,304, and we'll subtract that 2,304. So we have 6,400 minus 2,304, and that gives us 4,096. And we can try to take the square root of that, see if it's a perfect square, and it comes out to be 64. So when you take the square root of both of those, you find out that x equals 64. In the figure, we know we have two diameters. Often it's better to try to find the values first, and then you can come back and find all the individual answers. So here, if we have two diameters, then we have vertical angles. So this is going to be 42. This arc is going to be 42, and this arc will be 42. This arc will be 64. These three angles are going to add up to 180. So that's 106. So this is going to be 74. We can verify that mental math. We know it's 180, and we're going to minus the 64 and minus the 42. We got 74. So that worked out well. And then on this side, we have the remainder of 180 from 142, and that would be 138. Alright, so now we should be ready to answer all these questions. So the first one is PQ. The measure of arc PQ would be 42. ST would be 74. Those are degree values. TPS is everything but the 74. So you could call that 360, not counting the 74 degrees. That's 286. The other option would have been to add 64, 42, 138, 42. RT is adding up your two values together. 74 plus 42. You get 116. RQS, RQ, then S. So it's everything but the 42. So this is 360, not counting 42. So that should be 318. There's 318. QR, from Q to R, we already figured out that that was 138. PQS is 180 plus the extra 42. Looks like 222. And then we have TQR. TQR. So that looks like it is 180 plus the 64. So that's 244. Excuse me. On the flip side, we're looking for BC. Now we know it's 360 degrees all the way around. We have these two chords that have tick marks. That means these two amounts are exactly the same. So we have 2x plus 116, and that's going to equal 360 degrees. It goes all the way around the circle. So that should be 244. 244. So everything but the 116 is 244, and we divide that into two equal amounts. So each of these are 122 degrees. So that means that arc BC is 122 degrees. We're looking for this arc value, actually angle value. The angle, the inscribed angle, when the vertex is on the edge of the circle. You might want this on your note card. The inscribed angle is will be half the intercepted arc. So that means the measurement of angle ACB is going to be half arc AB, which is half of 130. Which is 65 degrees. So we're looking for ST, and we're also looking for SU. Now that's not phrased right. That should be STU because it's going to be 180. So it's going to be twice ST. Let's see, from T to U is going to be double that, so 122. So that makes this 58. So the measurement of arc ST is 58. And the measurement of STU, if that's what they meant, the measurement of STU is 180. Here we have 88. We're looking for JLM. It's going to be half of this amount. Well, if that's 88, this is going to be 92. This is 92, and this is going to be half of 92. So this is going to be 46 degrees. So the measurement of angle JLM is going to equal 46 degrees. And then we have KPL. So this angle is going to also be 92. Because they're vertical angles. VST, well, VST, that's an acute, or that's a small arc. It's called a minor arc, not acute, but that's a minor arc. It should not have 3 letters. So we could call that the measurement of, if you want, VT. That would include the 39. That's what we're looking for. Well, if this is 51, we know that the arc is going to be 102, because the inscribed angle equals half. If the vertex is on the side, it's going to be half the arc that it makes. Then we have 360 is the whole circle, minus the 39, minus the 102, minus the 135, .360 minus 39 minus 102 minus 135, that gives us 84 for that one. So if we're going to try to find the arc VT, because it's not VST, because that should be 3 letters, implies that it's 180 degrees or more. This is less than 180 degrees. So we'll just say V to T. That's 39 plus 84. $123. And then they're also looking for V to U, which we knew was 102. It was double 51. If we have a quadrilateral inscribed in a circle, then we know the opposite angles are supplementary. Let's put that on our note card. If a quadrilateral is inscribed in a circle, that's what we have. We have the vertices all on the sides of the circle. Quadrilateral, the 4-sided shape, is inside the circle. Then the opposite angles are going to be supplementary. So 104 plus 3y is going to equal 180. If we subtract 104 we're going to get 76 degrees. And we can divide that by 3 to figure out that y goes in there 2 times, which is 6 with 1 left over. Goes into there 5 times with 1/3. So to me that looks like 25 1/3. Oh, that's not a 3, that's a 2. That's going to work out better. That is a 2y. Did you just copy me? Or did you notice that? Don't be a copier. So we divided by 2. I went back and checked my work real close and I noticed that, hey, I wrote down the wrong number. That's going to go into there 3 times with 1 left over, so that's 38. That's better. And then the x value, we have 5x and we have 110. They're going to add up to be 180. Because opposite angles are supplementary if it's a quadrilateral that's inscribed in a circle. So x is 14. We're going to write the equation of the circle. Well, first you need to find the center of the circle. So our center is 3, 1. That's our h and k. And the radius is 2. So the equation of this, you'll want to write this down on your note card. R squared is going to equal x minus h squared plus y minus k squared. That's the equation of a circle. So in our case, we have 2 squared and we have x minus 3 squared plus y minus 1 squared. So the best answer is to call that a 4. So 4 equals x minus 3 squared plus y minus 1 squared. So again, if we have the center and we have the radius is 5, so we square that. X minus, this is your h and k, so x minus h squared plus y minus k squared. That's 25. This is going to be x plus 3 squared. And because you're subtracting 0, it's just y squared. Again, this is our h and our k. So our radius is 13. So we square that. And we get x minus 4 squared plus y minus negative 7 squared. 169. X minus 4 squared plus y plus 7 squared. Now here we have a center, which is your h and k, but then we have a point which is considered your x and the y. What don't we know? We don't know the radius. We're going to use the same formula. We don't know the radius, but our x is 6 minus our h is -1. Our y is 12 minus our k is 4. So we still plug it in to the same formulas we've been talking about. We're trying to figure out the radius. So this is 6 plus 1 squared and 12 minus 4, which is 8 squared. So our r squared is going to be 7 squared, which is 49, and 64. So that looks like 113. So we have 113 equals x plus 1 squared y minus 4 squared. Find the circumference of a circle if the radius is 4.5. Well, the circumference, you might want this in your note card, is 2 pi r, or we could actually do the circumference equals diameter times pi, because the diameter is 2 times the radius, so it's just the same thing. We're going to use the radius formula because they give us the radius. So the circumference equals 2 pi times 4.5. That's going to give us 9 pi. That is our exact circumference. And if we wanted a decimal version of that, that's going to come out to be 24.46. A car has tires with a diameter of 27. How far would it travel if it spun 1,000 times? So if we have a wheel with a diameter of 27, then the circumference is diameter times pi, so the circumference is 27 pi. So that's how far it is all the way around the wheel. And if you were to do that 1,000 times, we have 27 pi that's 8482. We're going to take our 8482 and times that by 1,000. That's just going to move our decimal spot 3 units to the right, and we get 84823. So we get an answer of 84823, and those are inches. So we could divide that by 12 to figure out how many feet. We could divide that by 5,280 to figure out how many miles that is. So it didn't ask for those details, but previous problems have. The arc length. We're looking for the arc length of A to B. That means we need to know this central angle. So 150 over 360 is going to equal the arc length of arc AB over the circumference, which this 34 is implying that it's across the whole amount. So it's diameter times pi. Alright, so we're going to cross multiply. We'll leave the 360 down here. So it's 150 times 34 pi divided by 360. 44.51. Those are centimeters. So here, the circumference, we're looking for the circumference, that's the distance all the way around. We're also looking for the radius. Well, if this is 260, and this implies that this is 81, so 260 divided by 360 equals 81.64 over our circumference. So we're going to have to bring the C up, bring the 360 up. So we have 360 times 81.64, and we're dividing that by 260. That gives us a circumference of 113.04. That's a circumference in inches. So the radius, we know that 2 pi r equals the circumference, so we're going to divide by 2 pi to get the radius by itself. So we're going to take that amount, we're going to divide it. You have to use parentheses. 2 times pi. Have to use parentheses. 17.99, practically 18. On the flip side, the diameter of a circle is 11. So if the diameter equals 11, then the radius equals 5.5. To find the area of a circle, you want this on your note card. This is pi r squared. So the area is going to be pi times 5.5 squared. 5.5 squared. So that's kind of your exact answer with pi. But if we times that to pi, then we get a decimal version of 9503. So we have 30.25 pi, which is approximately 95.03. And those would be centimeters cubed, or squared. Square centimeters. Areas are the tiles on the floor. The area of a circle is given. What is the radius? So if the area equals pi r squared, and we know the area is 236, we need to first divide by the pi, then take the square root. So 236 divided by pi, not e, but pi, that gives us 7512. And then we take the square root of 7512, and that gives us an approximated right, of the answer. You want to be exact, don't round your values. Now you can round your values, 8.67. And these would be inches, not square inches, because it's a length, it's a radius. Alright, here's another formula you want on your note card. We talked earlier over here, we talked earlier about the angle over 360 equals the arc length over the circumference, which is often 2 pi r. That's a formula you would want on your note card. Here we're talking about areas, so it's very similar. This is going to be the angle over 360, and this is the sector area over pi r squared. There's the formula you would want on your note card also. Alright, so this is a little tricky. Here they're giving us this area, this angle, but they're giving us the area of this portion. This is the sector, the big pizza slice. So we need to know this angle. So that's going to be 360 minus 161. So that's going to be let's see. If we minus 100, we get down to 260. So if we minus 160, we get down to 200. So we're at 199. So that is the angle that's over here. So that's 199 over 360 is going to equal our sector area, which is 84.14. And we want to know the area of the circle. So we could just write A. We don't have to find any special part of the area, so just area is fine. So we're going to multiply up, we'll multiply over. So 360 times 84.14. And we got some big number, and we're going to divide that by 199. We got 152.21. This is area, so it's meters squared. It should be more than what part of the pizza was. It's the whole pizza now. This one, find the area of the shaded sector. So we have 110. So we have 110 over 360 equals the sector area over the area of the circle. So we have pi times r squared. So So we're going to cross multiply there. Pi times r squared times 110 gives us 56,619. That's these two multiplied together. Then we divide it by 360. It gives us 157.28. Area of the sector. And these are millimeters squared. Square millimeters. Then we're going to find the area of the shaded region. So it's all of this, not including the circles. So if it's 32 all the way across, that would make that 8 plus 8, which is 16, 24, 32. So it's 8 as a diameter. So that means the radius of each of these circles is 4. That means the area of every circle is pi r squared. So that's approximately 50.27. Now there are 1, 2, 3, 4, 1, 2, 3, 4, so 16 circles total. So we're going to take our real answer and times it by 16 because there are that many circles. Those are the amounts that we don't want. 50.27 times 16 equals 804.25. Now the full square is 32 times 32. That's 1024. And when we minus our 804 from that, we get 219.75. And those are centimeters squared, square centimeters. Here we're looking at the perimeter. We want to know the distance around the whole piece. So if this is 7, that makes this 7, which makes this 7, which this portion is also supposed to be 7 and 7, and 7 and 7. So we have 14 times 3, 14, 14, and 14. Then we need half the circumference, plus we're going to do half of 2 pi times 7. So this is 52 plus 7 pi, that's kind of the exact answer. And in the decimal version, 52 plus 7 pi. That should be 73.99. These are meters. Alright, those are your circles.